Hello everyone and welcome back. My name is Mr. Covalent, and in this video I'm going to talk about how you can go from the name of a binary covalent compound. How do you get the name of the binary covalent compound from the formula? So let's get into this. So the first thing I want to talk about are common names. So the common names are the names that are commonly known for certain substances. They're not scientific. It's just names given to them by, say, the general public over time. So, for example, we have H2O, which is commonly known as water, right? And if you've seen NH3, that would be ammonia. So ammonia and water are common names for these substances, for these formulas, okay? But they also have scientific names that we won't really get into just in a moment. We'll get into that. So CH4 is known as methane. C2H6 has a common name, ethane. And C3H8 has the name propane. So these are common names of these substances, but they're also scientific names that you can give to certain binary substances as well using this system here. So when you're naming your binary covalent compound, let me just go back and kind of explain what a binary covalent compound is. Binary means two, so this would be a covalent compound that has two different elements bonded together. So, for example, we have hydrogen and oxygen, nitrogen and hydrogen, carbon and hydrogen, all of these. So, these are examples of binary covalent compounds. They're covalent because they're all nonmetals. You have two nonmetals bonded together. In a previous video, I talked about ionic compounds. That would be where you have a metal and a nonmetal for the most part, but you don't necessarily always have a metal and a nonmetal for the ionic compounds. For example, you could have NH4, which is ammonium. That's an ion, and then so it's a positive ion, and so that would be all nonmetals. But I digress. So in this video, we're talking about binary covalent compounds. And so when you're naming when you're using a scientific notation or scientific way of naming, the way you name the binary compound, the binary covalent compound, is the use of prefixes. So the prefixes are these prefixes here. So you're going to put a prefix at the beginning of the name of each element. So we need a prefix that's going to determine or indicate how many atoms of that particular element you have. So mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. And that's as far as we're going to go. You can go further than that, but 10 is enough. So depending on how many of each atom you have, that's going to determine what prefix you put in front. So if I have two of that element for my first element, I would put di. And then it's going to be the name of whatever that first element is, followed by the second element with its prefix. So it's going to have a prefix plus the name of that second element. But that second element, you're going to drop the ending and add IDE. So the second element's name is going to end in IDE, but you got to drop the ending first, right? And so certain endings are dropped for certain elements, and I'll go over that in just a moment. So what's in a good example? I have a good example. So N2O3. So N2O3. Well, how would I name that? Well, it's going to be the name of the first element with a prefix added, and the prefix is going to be indicated by or determined by how many of that element I have. So here, you'll notice I have a 2 subscript. So that tells me I have 2 nitrogens in this molecule. So I'm going to use the prefix di. So this is nitrogen. So it's going to start with di, or maybe I should write it. I'll write it over this side. That way I can have more room. So this is going to be dinitrogen. So notice that it's the prefix plus the name of the first element. So nitrogen is the first element, and I have a 2, so the prefix is di. So it's dinitrogen. And then that's going to be followed by the second part of the name, which is the second element here. So notice I have oxygen. I have a 3, and so that's going to be tri. Maybe I will move that down a little bit. I'll put that over here. So dinitrogen. Sorry about that. And so I have a 3 here for the oxygen, so it's going to be tri. But it's going to be the name of the oxygen, but I'm going to have an ID ending. So I got to drop the ending of oxygen and add IDE. And so when we drop the ending of oxygen, right? So oxygen, we're going to drop the YGEN and we're going to add IDE to the end of that. So it's going to be trioxide. So oxygen becomes oxide. And you only do that for the second element. You don't do that for the first element. The first element is just the full name of that element. So let's go ahead and do another one. What about P4O10? Right? So same thing. I'm going to start with the first element, which is phosphorus. And so it's going to be the prefix followed by the name of the first element. So the first element is phosphorus, and the prefix is determined by the subscript. Here I have a subscript 4. 4 is tetra. So I'm going to have tetraphosphorus. So there's tetraphosphorus. And then, so I've got the prefix and the name of the first element. Now it's going to be the prefix plus the name of the second element, but with the ending dropped and adding IDE. So again, the second element is oxygen again. So we're going to drop the YGEN ending, add IDE, but we need the prefix for 10. So 10 is deca, so it's going to be deca oxide. Okay, but hold on, we're not done yet. Now, deca oxide, that's not quite right. So in this case, what's going to happen, notice that I have 2 vowels next to each other. I have A and O. Whenever you have an A and an O together, or an A and an A together, or an O and an O together, you drop the first you drop the first vowel, which is going to be this vowel here, right? So here, deca oxide is not going to be quite right. I got to drop the A. That's why the A here, you'll notice the A here is in parentheses. That means that A is going to be there sometimes or not. If the A ends up next to a consonant, then you keep it. If it ends up next to a vowel, you're going to drop it. Keep the second vowel. So in this case, we would drop the A and we would write dec oxide. So it's not deca oxide, but dec oxide would be the right way. Now, if you look up here, you'll say, well, Mr. Cobalt, you have an I here and you have an O, you have 2 vowels together, why not drop the I? Well, that's an exception. I's are okay. They can be next to a vowel. They can be next to an O. Excuse me. They can be next to an A. They can be next to an I. You can have 2 I's together. So an I is fine. But A next to A, O next to O, A next to O, those aren't going to work. You got to drop the first vowel and keep the second one. So I and O next together is fine. So notice that the A here is next to a consonant, so we keep the A. But here the A is next to a vowel O, and so we're going to drop the A. So tetraphosphorus dicoxide is the name of that substance. So that is how you name your binary covalent compounds. There's one thing I want to go over before finishing this video, is that what if you have a hydrogen with a halogen? Well, in that case, you can use the way of naming, right, that's shown here. You can do that. But a lot of times, you just drop the prefixes altogether. So, for example, if I have hydrogen plus, let's say, Cl, HCl. Oops. Sorry about that. So here I have HCl, and so how would I name this? Well, if we're going to use the scientific way of naming, we would say, there's one thing I forgot. I'll do this as an example. So if I do CO2, this would be carbon, and I only have one carbon here, so you might think that I could use the prefix mono. And so you would be correct normally, but in this case, we don't use mono for the first one. And don't ask me why. I'm sure it's got historical reasons for it. But for whatever reason, we don't use mono for the first carbon. If you know why we don't use mono, if you happen to know that, put it down in the comment section. Let me know. I could probably look it up later. But if you know, go ahead and put it in the comment section. So for whatever reason, for the first element, if you've only got one of that first element, you don't use a prefix. You don't use mono. So this is just going to be carbon. This is the only time you won't use a prefix when you're naming your binary covalent compounds. Of course, this is another exception here. I'll get back to that in a moment. So here I have carbon. So the name of this would be just carbon. And then oxygen is just normal, right? So I have two oxygens. Again, it's going to be the prefix 2 for di. So it's going to be di for 2, and then oxide. So carbon dioxide. Now, if I had CO, it would be carbon monoxide. So CO, I'll just write that really quick to be complete. CO, again, I only have one of the first element, carbon, so no prefix in that case. So carbon. But I have one of the second one, I will use mono for that one. And again, mono and oxide, monoxide is not quite right because I have two O's together. I'm going to drop the first O and just keep the second one. So monoxide, not monoxide, but monoxide. And there you go. So again, the only time you're not going to have a prefix when you're naming is if you only have one of the first element, like here and here. So carbon, not monocarbon, but just carbon. Okay, so back to our hydrogen plus halogen. So here, you don't have to use prefixes. A lot of times, you're not going to use prefix for this, so you might run across the name of these in that way. Okay, so here I have HCl. So the name of this would be hydrogen. Right, just like I said just a moment ago, we don't write mono for the first one, but for the second one, you could write mono, right? So we might say monochloride, right? So monochloride. chloride. That would be one way to name this. But a lot of times we don't even write mono for this one. So if you have a hydrogen plus a halogen, remember the halogens are the group 7A elements. So we could just forego having the prefix, and we can just call this hydrogen chloride and not have any prefixes. So hydrogen chloride, we could do the same thing with HBr. That would be, oops. Sorry about that. So here we could have hydrogen bromide and so on, hydrogen iodide and so on. And then in addition to that, we could do the same thing for H2S. So here you could say this is dihydrogen monosulfide, right? That would be the way to name this according to this way of naming, right? But again, this is one of those ones where a lot of times it's named without any prefixes. So instead of having di and mono, you could just drop those and just call it hydrogen sulfide. Hydrogen sulfide. Oops, let me fix that. So hydrogen sulfide is a common name for this substance as well. So these are kind of exceptions to this rule here. Okay, so that's how you name your binary covalent compounds. Again, you can have your common names, or you could have this way of naming, which is the more scientific IUPAC naming system for your binary ionic compounds. And again, keep in mind that these, if you have a hydrogen with a halogen, those typically will not have prefixes, although you can name them with the prefixes like according to this way of naming. So that's it for this video. If you enjoyed this video, if this was helpful in any way, then please by all means like the video, share the video with your friends, hit that like button somewhere over here maybe, or I don't know where it's at, find it, click on it. Also, make sure you subscribe to my channel. When you do, click that notification bell. I keep forgetting what that is. Click the notification bell. Let me know when you do that. Click all so you can be notified by all the videos I put out. And also put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem you want me to help you solve, if you have a question you want me to answer, if you have a topic you want me to cover, then put that down below. I would love to do that for you. Thanks for joining me and have a great day.